routing protocol for Internet of Everything. In this we have to study a deep technical drive in RPL unloading with real-time deployment examples. So in this we have IPv6 adaptation layer and DOD-G routing, header compression and low power lossy networks. These are the routing protocols for this IoE, and what we will cover in this is we have a 6 LoRa WAN, that is a name that is it deals with IPv6 adaptation layer for constrained wireless devices, then protocol stack and header compression, and these deals with sequencing IPv6 onto 127 byte of 802.15.4 frames for these things, and RPL, that is routing for low power lossy network, that is DODAG construction, which gives an architecture and live examples, and load-ng on demand routing, reactive AODV derived routing, gives architecture and live examples, and we have a comparison and selection framework. Selection framework for this, for choosing a right routing strategy for these IoE networks. So the right routing strategy involves different ideas with different routing platforms. Where 6 LoRaWAN, this is IPv6 over low power wireless personal area networks, that is RFC 4944 and RFC 6282, an adaptive layer that lets full IPv6 packets travel over tiny low power radios such as IEEE 802.15.4, making every sensor a first class internet citizen. That's an example, actually that doesn't make sense. And here we have a thing that is a problem, that is IPv6 assumes as a that is 1280 bytes MTU and 40 byte header, with IEEE 802.15.4 frames are only just 1 or 2 bytes total on battery powered and memory constrained chips. Here we have a fix, that is adaptive layer, that is 6 LoRaWAN sits between IPv6 and MAC layer, compromising headers and fragmenting and reassembling packets, and that to act as transparent one. And why it matters for us, that is every device gets globally routable IPv6 addresses. No proprietary gateways are available for this, enabling the seamless end-to-end Internet of Everything connectivity over it. So here are some protocol stack and header compression, that is application layer, physical layer, MAC layer, adaptation layer, network layer, transport layer, application layer. So all these things are creative structure, where physical layer is IEEE 802.15.4 physical layer, that is 2.4 GHz and sub GHz, and MAC layer, that is IEEE 802.15.4 MAC available in it, followed by adaptation, that is 6 LoRaWAN compression and fragmentation, followed by network layer, that IPv6 plus RPL, followed by transport layer, that is UDP. So these things are very relative with CoAP, that is MQTT, SNP. So this MQTT and SNP are given, and here it gives with compression and fragmentations, that are very essential parts, that is 40 of 2 bytes, that is IPv6 and UDP headers compressed via IPHC, that is RFC 6282, by yielding fields that interferable from link layer context. Then 1280 bytes, that is a minimum of IPv6 MTU that every packet must support end to end per RF 2468. It gives some ideas about that. Then 127 bytes, that is total IEEE 802.15.4 frame size, that is it is a large IPv6 packets and must be fragmented across several frames. So from this case of understanding, we deal with these 1280 bytes and 127 bytes with misunderstanding. So the misunderstanding seems to be very in par with things that deals with the protocol, that is stack and header and compression protocol, that is physical layer, MAC layer, adaptive layer, network layer, transport layer and application layer. So for all these layers we have some infinite form of applications available. And routing channel. So routing channels in low power lossy networks. Low power lossy networks, it deals with IoE networks, that is low power and lossy networks, that is thousands of battery powered nodes like unreliable radio links and dynamic topologies and traditional internet routing protocols. All these are abundant in nature, and they find with several reasons to connect all these things with links and things that deals with more informational point of view, that is lossy dynamic links and low area networks, then massive multi-hop scaling methods and energy aware signaling methods. So all these things comes together to create mindful of experiential things, and those experiential things will create more legitimate form of connectivity, establishing a fantabulous connective process for all these steps with an idea of creating a frequent resonance in resources, dynamic links and massive multi-hop scaling methods and energy aware signaling methods. So all these things comes together to create a full and routing channel in the low power lossy networks, and these lossy networks gives some routing protocol types like this, that is routing for a low power and lossy networks, where we stand with a standard IET role working group and followed by a proactive distance vector and building a DODAG routed at a bordered router, then topology, that is destination oriented tag, then nodes ranks themselves by distance from these routes, and objective functions, that is OFO, hop count, or MRH of that is min rank v hysteresis using ETX, and control messages like DAO and adverse ranking and DADA report downward routings like DAS, solistics and DAO. So all these are control messages, and with this the modes like storing per node routing tabs and non-storing routing from all these areas are available. So all these things are come together to create a mindful of tracking mechanism to follow these routing for low power and lossy networks. So this gives more information about these routing protocols. Then with this we will go with a smart grid advancement metering infrastructure in the next video. Thank you.